Today I'm going to talk about LeetCode question number 139, word break. So given a string s and a dictionary of strings, word dict, return true if s can be segmented into a space-separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in a segmentation. So I can illustrate this with an example here. So we have the string LeetCode and our word dictionary contains leet and code. What we output is true because LeetCode can be segmented into leet and code. Second example, apple, pen, apple. And we return true because apple, pen, apple can be segmented as apple, pen, apple. And here we see the word dictionary has apple and pen. Okay. And the last example is actually false. And why is this false? Because we can't segment this string into words that are contained in the word dictionary here. So we can try like cats and og. Og is obviously not in here, so that can't be it. We can try cat, sand, og, still not it. We can try cats and dog, still not it. This is not in the word dictionary here, etc. So no matter what we try, we cannot segment this separately into words, into space-separated words that are contained in word dictionary. So how do we go about this? Well, the brute force method would be to check each and every word. So let's take this example, LeetCode here. Or actually, let's take this example. So we have our decision tree, okay? We can go with, if we go letter by letter, I'll write it out. So if we go letter by letter, C, is it in word dictionary? Nope. A, CA in word dictionary? Nope. CAT in word dictionary? Yep. So we have one decision here. We can go with cat, okay? And then next word, or we could have gone with cats. So that's another decision we could have taken. So if we look at this cat decision, we could go S, not in dictionary, then SA, not in dictionary, SAN, not in dictionary, sand, okay, sure. Okay. And we find out we can't go any further because no word in this dictionary here starts with O, let alone is og. So we stop here and we return false. But what about the decision for cats? So we took into account the word CATS, and then what other decisions could we make? Well, we could have, so since we took cats, we go and, because this is in the dictionary here. But then we cannot take og because it's not in the dictionary. So unfortunately we have to stop here, and this returns false. Okay, and what about this example? This is a valid example here. So in our decision tree, we could go with, apple. And then as we iterate through each character, we find the word apple, and it's actually in here. What if we had another word called apple? Then another decision we could take was apple EP. Okay, and with this apple, we could have gone with pen. But what if we had another word called pen a? Then we also could have gone with pen a here. Okay, and etc. So, and then obviously this would resolve to apple. So we can take this path here, pen a. If we do take pen a, then the remaining letters would be P, P, L, E, which obviously is not in a word dictionary here, so that resolves to false. What about apple, EP? We have these strings here. Obviously, we cannot go on any further. That remaining string here, E, N, A, P, P, L, E. Obviously, it's not in a word dictionary here, so we have to stop here. Okay, and then this resolves to true. We need at least one true in order for to return true. So as you can see with the brute force solution, this tree can get larger and larger, and this eventually goes to exponential time. Okay, so how do we do this better? How do we do it efficiently? Well, instead of like top down dynamic programming, we can also do true dynamic programming of bottom up. So how do we do this? Well, instead of a decision tree here, what we can do is have an array. So let's do this example of LeetCode. Okay, and we have an array. Right now, everything in this array is going to equate to false, except for the very last element, which is going to be true. Out of bounds for a string here, but it's going to be true. Okay, and then yeah, so basically we have our base case here, which is true. So if we were able to go through this whole string and reach the very end of the string successfully, finding the proper words in the word dictionary here, and we're able to reach the end here, then obviously it's true. So that's our base case. We're actually going to work backwards here. So what we're going to do is, similarly with our top-down approach, work backwards letter by letter and see if the string we're building with our letters is in our word dictionary here. So, for example, E, not in our word dictionary. I'll change colors. Not in our word dictionary of LeetCode. So, yeah, we ignore that. So we move on from that. DE, nope. ODE, nope. CODE, actually CODE is in our word dictionary here. Okay, so now what do we do in this case? Well, CODE is in our word dictionary, and then we have to check. So we found this word in a word dictionary. What about everything after this word? Was that also in a word dictionary? Since it's our base case here, it's going to be true. So we look after this word. This is true. So this is going to be true. And similarly for the leet up here, I'll change colors again. So we look at T. T is not in our word dictionary. ET, not in the word dictionary. EET, not in word dictionary. And LEET, that is in the word dictionary. Okay. So what we do now is, since LEET is in a word dictionary, we check after this word. Is everything after this word able to be properly segmented into space-separated sequences? We found out, yes, this is true. So everything after here was able to be space segmented. So now what we do is change this to true. Okay. So finally, we're at the end of our iteration here, and what we do is return the very beginning of this array, true. Okay. So that's how we're gonna go about it. Similarly for cats and dog, this S here, if this is true and the rest are false, if we iterate backwards, G is not in word dictionary, OG not in word dictionary, DOG in word dictionary. Okay, so this is true here. Well, these are false. What about N in word dictionary? Nope. AN, SAN, TSAN, ATSAN, etc., etc. And we find out, while this can be segmented, this cannot. Okay, so therefore this will be false. This will stay the value of false and we return false. So that's how we're going to go about it. And the time complexity of this is going to be O of N times M, where N is the length of S and M is the length of a word dictionary here, because we're going to have to iterate through word dictionary in order to find if for some string here it's in the word dictionary. For the string we have so far, it's in the word dictionary. Now to code this up, so what I'm going to do is create my DP array, which is going to be false, and its size is going to be the length of S plus 1. Okay, remember plus 1 because if we have LeetCode here, then we want each position in the array to represent an element here, and at the very end, slightly out of bounds, that will be our base case, and this base case will be true. Okay, so that's kind of all we need there to prep. So now I'm going to iterate through the string backwards. So for I in range length of S minus 1, okay, what I'm going to do here is iterate through also words in word dictionary. So for word in word dictionary, and now I want to compare if the current word I'm looking at, like if we start from back here of LeetCode, I want to check if this word is in word dictionary. If not, I move on, and then finally I'll see code is in word dictionary here. And then and then I'll set the C to true. So if what I want to do, check first if it's in bounds. If I plus length of word less than or equal to length of S. So why did I check this? Well, if we have a word dictionary here, which I'm just gonna copy here, and we're iterating through this word S backwards. So if I'm at E and compare it to Leet, I need to check obviously if E is the same size as Leet, obviously not. Or if Leet is within bounds of this current string I'm working at, obviously not, so I move on. And it'll be the same here, and then eventually get to code here, and then the index of C is 0, 1, 2, 3, 4. So 4 plus the length of word 4 is less than or equal to length of S, which is 8. Okay. So basically it's in bounds of S, the word I'm comparing with. So basically the word I'm seeing here is within bounds of S. Okay. And S and then what I want to do here is split S just to get that word there. So I to the I plus full length of word. So for like position index 4 here, 0, 1, 2, 3, 4, okay. And then I plus length word would be leet in this case, so 4, 8. So 4, 5, 6, 7, and 8 would be out of bounds. But it's okay because when we truncate split strings like this, then this last guy is non-inclusive. So equals word. What I want to do is set dp of I to be equal to dp of I plus length word. Okay. So we check 1 after the length word. So again, if we were at C, and then this is index 4, plus length word, it was 8, so 4, 5, 6, 7, 8. And in our DP array, this very last one is true, so this is going to be set to true. And then we want to check if DP of I equals to true, then just stop looking and continue on with this main loop here. Okay, so basically we would have that code done. And what about for this portion leet here? So you look at T is obviously not in word dictionary, okay, because this index is 0, 1, 2, 3, S of 3 to 3 plus length of word, which would be, I guess, leet 7, so 3, 4, 5, 6, 7. T code is obviously not in word dictionary, so we move on to ET, same thing, EET, same thing, and then we get to L. Okay, now this gets interesting. So this index of L is 0, so S of 0 to the range 0 plus length word, 0 to 4, so 0, 1, 2, 3, 4, and since that is non-inclusive, it would actually be up to 3, leet, and then we see leet is in word dictionary here, over here. Then we check 1 after, so if this is in word dictionary, are all the other letters after be able to be segmented? And we see from our previous work that C is set to true, which means yes, everything after here was able to be truncated or segmented into space separated sequence. So then we set L to true here, and then obviously since we're done iterating through this string S, we're done. And finally, what we want to return here is return dp of 0. Okay, so I'll take this for a dry run. Okay, and I'll submit. Okay, great. Thanks for watching.